Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me for yet another video on the Rust programming language. Now, the topic that we're going to be covering in this particular video actually expands on the topics that we covered in the last couple of videos if you're following along with my Rust programming tutorial playlist. And those two videos covered the creation of custom user-defined data structures in Rust. And the last one, the most recent one, actually covered how to implement methods or behaviors on your custom structures. Now, something else that's really important to understand in Rust is the ability to use something known as generics. The documentation does a pretty comprehensive job of describing generics, as well as a corresponding feature of Rust, which is known as traits. So, generics and traits work very closely hand in hand to allow you to define common sets of behaviors across the different data structures that you're defining within your application. Now, data generics or struct generics, I should say, can be used in a variety of different places here. So we can define them on structs themselves, and we can also use them as function parameters as well as output argument declarations as well. So there's a variety of different places inside of your Rust code where you can specify the use of generics. Now, I like to kind of demonstrate the behavior of traits before we go into generics because understanding traits first actually helps you to better understand why generics are necessary. So let's go ahead and actually talk about traits, how to define a trait, and then how to implement a particular trait for a type, like a struct that you've defined in your code. Now, if you're coming from some other programming languages, then traits might be familiar to interfaces. But unlike C# interfaces that allow you to declare properties and methods, traits inside of Rust only allow you to define method signatures that you want to associate to your data structures. It's the same with Go as well. If you're coming from the Go programming language, then you'll probably know that interfaces in Go only work with methods. They don't allow you to define common properties or fields across your different data structures. So essentially what a trait is it's an object that we can define in our code, in our modules in Rust, and we can specify certain methods or functions that should be associated with our type that should exist as an implementation on that particular type. Now, if you recall from our previous video, we had created a couple of different types of structs here. We had a vehicle struct, for example, and then we created this implementation block here where we implemented an instance level method that allows us to paint an existing vehicle. So if the vehicle starts out as white and we want to paint it blue, we can simply call this associated function on the vehicle type, and that will affect the current instance of the vehicle that we are dealing with. And the same thing applies to other types. So we have like a person type here, and we can implement a method on the person type that says if we call walk meters on a person, it causes that specific instance of a person like me or you or someone else to actually advance that particular distance as an attribute of the struct itself, right? So what we can actually do is take these different methods that we are defining on our data structures and implement them as a common interface of behaviors. Now, why is this important? Well, let's take a look at an example for starters here. So I'm actually going to bring in a new code file into our project here. Let's just define a new file called testtraits.rs. And inside of here, after I import this into my main function, let's comment out our test create person from our previous videos, and let's declare pub mod and test traits. And so that will allow us to get the Rust analyzer fully working with this particular file. So now let's open up this test traits file, and we are going to define a couple of data structures, right? So let's do a struct called a dog, okay? And I'm not going to add any fields in this for now. We're just going to have a dog type. And then let's create another struct called a cat type. So, a dog and a cat are two very common types of pets that you might come across, and each of those different animals makes their own unique type of sound, right? Dogs bark, cats meow, that's just how it is. Tigers maybe make a roaring sound, bears, that's another type of animal, maybe they make a roaring sound as well. And so, that roaring or barking or meowing is a common set of behaviors across different types of animals within our application, right? So rather than just going off and implementing a method here, like implement dog, and then say, let's create a function here called bark for a dog. So what we'll do is just say bark and then put in our body and just say print line bark. And up here, of course, we would pass in self, right? So normally what this would do is it would just go to the dog struct and it would associate this bark method or function. It would associate it with the dog type so that when we create an instance of a dog, basically referred to as ampersand self right here, a pointer to self, then it'll just run the code inside of this associated function. But rather than just having this unique bark method on a dog, where we have to call bark on a dog and we have to call a meow method on a cat, wouldn't it be easier if we just had a generic function called make sound or something like that, that we could call on any type of animal? So if it's a bear, the make sound function is going to roar. If it's a tiger, make sound is going to roar. If it's a cat, then the make sound function will meow. And if it's a dog, then the make sound function will bark, right? And so this gives us a common interface to the different data types that we declare inside of our application. If you take the character approach in a game, let's say that we had a struct like character. Okay, so this is your in-game character. And let's say that you had a character that was a mage or an archer or a warrior. Well, your structure here is probably going to have some kind of field like hit points that keeps track of the number of hit points that the character currently has. And this is U16, not uint. So every character, regardless of what character type it is going to have hit points. And maybe a warrior has a different number of hit points than a mage or an archer, but if a character is damaged by an attacker character, like some kind of enemy, like maybe a wizard or maybe another warrior or a ghost or something like that, then the hit points are going to take some damage, right? So rather than implementing a unique damage method for every single character type out there, we can instead just declare that common behavior as a trait, and then we can implement the specific implementation for each of those different specific character types. So hopefully that makes a little bit of sense. I know it's kind of wordy, but hopefully this will make a little bit more sense as we continue here. So in any case, let's say, for example, that we have a struct person here. And the struct person, maybe you at home, maybe you have a pet, right? Maybe you have a pet dog, maybe you have a pet cat. We happen to have 3 dogs of our own. So let's just say that a person can only have one pet though, right? And so we want to give them a pet property here, and we want them to have a pet type as the pet, right? So what we could do is say pet is going to be of type dog because we have a dog struct down here. But now if a person owns a cat, then we can't assign a cat instance to this dog pet property, right? Because it's of type dog, it's not of type cat. Or if somebody had a pet bear or a pet tiger or a pet antelope or whatever it may be, then this struct right here is too specific, right? It's only allowing us to have a dog. So instead, we would have to define other types of structs, and this just complicates our code. So what we could do is say person with cat, and then change the pet type to cat. We could paste it again, and then say pet is type of bear, which we haven't created yet. We could say person with bear, and this one, maybe we could say person with dog. And so as you can see, we've got several different structs here, each depending on what type of pet that particular person has, right? Well, as we expand the number of animals, we have many, many different permutations of our data structures here, and all of them have to be implemented uniquely, right? So generics allow us to actually declare a pet field on a generic person type so that we don't have to duplicate all of this code and declare different data structures for each of these permutations. So rather than declaring the type of pet as a dog, what we can actually do is say something like animal. Okay, now we haven't defined animal yet, but animal is going to become a trait, which is a kind of declaration of certain behaviors of data structures inside of Rust. So if you think about it here, a dog is an animal, a cat is also an animal, and we could go ahead and add other types of structs in here, like a bear. Maybe you have a pet bear. I hope not, but maybe you do. We'll do a struct of tiger here as well. And so each of these 4 different types of animals are animals, right? I don't know why I said that, but you get the idea here. So what we can do is use traits to declare all of these different animals as animals. So what we'll do is say trait animal, and we don't even have to put anything inside of the body of the trait itself. So what you're going to see is that we can implement this trait called animal on each of these structures down here. And once we implement this particular trait, that will allow us to use it as a generic type on our person object here. And then a person can have any type of animal as a pet that it wants, right? And again, just keep in mind that for this example, we're just referring to a person having a singular pet. We're not going to get into arrays or vectors or slices or anything like that. We're just going to keep things relatively simple and just have a scalar value for the pet field on our person type. So what we need to do in order to fix this issue here, you can see it says trait objects must include the din keyword. Well, what we need to do is declare this trait down here as a generic type for person. And the way that we do that is with these angle brackets here, so less than and greater than. And inside of these brackets right here, we just specify a term. So we could do something like pet type. And so this is a generic declaration that we can then use inside of our application here. So what we're going to do is say pet type, and then, in order to specify what the pet type actually can be, because right now this generic can accept literally any type of data as input. It could accept an unsigned 8-bit integer. It could accept a floating point 64-bit value. It could accept a string value. It really doesn't matter at this point because we have no boundary as far as what types we can assign to this generic. So what we do is we implement something known as trait boundaries, where we can restrict the pet type generic type to be only certain trait implementations. And so what we want to do is use our animal trait right down here in order to specify that the pet type right here has to be implementing the animal trait. And so what you're going to see is that at the moment, let's just get rid of this implementation block down here. So at the moment, none of our animals that we have right over here implement the animal trait. And so right now, we would not be able to assign an instance of a dog or a cat or a bear or a tiger to the pet field on a person instance. So let's actually try that out and see what happens. So let's declare a public function here so we can call it from our main application entry point. And we're going to say create person. And inside of this create person method right here, or function right here, we are going to create a person for starters. And let's just give a person a first name just so we can uniquely identify the person. So we'll just make that a string value. And then we'll say, let's create a person. So let's do let p1 equal person, semicolon. And right inside of here, we specify our fields. So first name will be Trevor.toString. And then our pet field right here is going to be a pet. Now we want to go ahead and construct that pet so that we can pass it into this data type when we construct it, the person type, right? Because right now you're going to see that the person type has an unknown generic because we haven't specified anything for the pet type yet, right? So what we need to do is declare our pet. Let's do let pet1 equal a dog. And then if we try to pass in pet1 right here into our function, you're going to see that we get this error right here. So let's try to do cargo run. And you're going to see that the person right here has a specification that requires a bound. And so what we're saying is that the animal trait must be implemented for this pet type here. So in order to fix this, we actually have to implement the animal trait on the dog type because we tried to assign a dog to a generic type that accepts an animal. So what we can do for this trait here is just go right under our dog struct here, and we're going to create an implementation block here. And normally you might just say impl dog. Well, in this case, we need to specifically implement the animal trait for the dog struct type. So what we do is we say impl animal for dog. And so when we use this syntax right here, impl trait for type, that basically associates that trait with the type, and that requires that this type, like dog, for example, implement any function signatures that have been declared in the trait. At the moment, our animal trait doesn't actually specify that any function signatures must be satisfied, so we can literally just have an empty implementation block for the animal trait on the dog type, and that satisfies the trait. So now that the dog type has implemented the animal trait, you should see that that error disappears here on the line where we construct the person. And if we do a cargo run, let's actually make sure that we call that from our main function here. So we'll go into test traits and call the create person function that we publicly exposed from this module right here. Let's just do a cargo run, and everything works perfectly fine here. Now, of course, we do have some warnings here from the Rust analyzer just because we are not actually using any of these structs. And so obviously you don't want to have just dead code sitting in your project. So since we specifically want to allow these, we'll just do allow dead code. And we can copy that attribute down to each of these types so that we can get rid of that warning. All right, so at the moment we have a struct. We've declared a pet type of the animal trait, and we have a pet field here that takes the animal trait and allows anything that implements the animal trait to be used right down here. So now what we can do is implement animal for these other types down here. So we need to implement animal for cat, right? Actually, let's just comment this out and I'll show you what happens if we don't do that. So let's comment these out and then let's try to change this down here. Let pet2 equal cat. So we have an empty cat here. And now what we're going to do on the person, when we instantiate the person, we're going to change pet to pet2, which is a cat, not a dog. And as you can see, we're back to square one with our trait because the trait animal is not implemented for the cat type. So that's what you're going to see if you try to pass in a generic, but you have the trait boundary that specifies that this trait must be implemented on whatever data type is being passed in for this type here. So what we want to do is implement this for cat. We'll implement it for bear, and we'll implement it for tiger. So we'll save that, and that should automatically fix our issue here because pet2 is a cat. Cat now implements the animal trait, and so that works perfectly fine. And we could just duplicate this code a couple more times, do pet3, set it to a bear, and then we'll do pet4, and we'll set it to a tiger. All right, so now we have 4 different pets, and regardless of which pet we want to use, let's try pet number 4, which is a tiger. You can see that that compiles and executes just fine. We could do pet number 3, which is a bear. Again, hopefully you don't actually have a bear as a pet. I don't either. Probably not many people do except for zoos. But as you can see, that compiles and runs perfectly fine as well. All right, so that's how we can declare the generic type on our struct. But at the moment, our trait right here doesn't have any functions that are required to be implemented on each of these types down here. So what we do inside of the trait body here is we specify a function that we want to be common behavior on any type that implements the animal trait. So as we talked about before, all of these different 4 types of animals make different types of sounds. A bear is going to roar, a tiger is going to roar, a dog is going to bark, and a cat is going to meow. So what we want to do is make sure that we implement some kind of generic make sound behavior on all of these different types, right? And then we'll implement the actual specific behavior for each of the different types in our implementation blocks. So what we'll do is create a function here called make sound, and we're going to accept self as a parameter because this is going to be an instance level method that we call on each instance of the type. So we don't want to just call it on dog generally because dogs as a concept don't bark, specific dogs bark. So what we're going to do is just go ahead and return nothing. So we'll just return a unit type there, and we'll just put a semicolon to terminate it. So this is all we have to do for a trait. All we do is we declare the signature of the function, which includes the name of the function, the input arguments here, and any return types as well. But then the actual implementation of this particular function, or in this case method, because it's associated to types, is to go down to the implementation block for each type that implements animal. And you can now see that it says not all trait items are implemented, and it specifically even tells you, this is the great thing about Rust, is it's very specific and tells you that the make sound function is missing from the implementation for a dog. So all we have to do is just start typing here, and automatically from the trait definition right up here, the signature of the function is auto-completed by the Rust Analyzer extension for Microsoft Visual Studio Code, and it automatically knows the name of the function, the input arguments here, if applicable, and the return type of the function. So we can just auto-complete the definition of the function, and then we'll just do print line dog barked. So what we're going to do is essentially just copy this implementation here and use that similar implementation for each of our animal trait implementations. So we'll go down here and say cat meowed, and then we'll copy that again, come down here to the bear implementation and say bear roared. And I think we're going to use the same thing for tiger. I'm not really sure if there's a difference between a tiger roar and a bear roar, but we're just going to say tiger roared. So as soon as we save this project right here, you can see that all of our errors disappear. Everything should compile just fine here because all of our different data structures that implement the animal type are now implementing the make sound function with the appropriate input and output types. So now when we specify something like pet3, which is a bear, we should be able to do cargo run. And of course we need to call that method. So let's do p1.pet.makeSound, because whatever the pet is for the person, regardless of what type it is, we want to make that sound for it, right? So what we're going to do is do cargo run, and because pet number 3 is a bear, we have bear roared. Or if we change the pet to, let's say, pet number 4, you can see tiger roared. And if we change the pet to pet number 2, we can see cat meowed. And if we change the pet to pet number 1, we can see that the dog has barked. So by creating a single struct type here to represent a person, and by using Rust's generic type argument, along with what's known as a trait boundary here to specify what valid input types are allowable for the pet type, we were able to just use a single person struct rather than defining separate structures for each person for each animal type that we implement. Because if we implemented 50 different types of animals into our Rust application, we would have to have 50 different types of person structures that each allowed that specific type of animal. But using generics, we only need one implementation of person, and that satisfies any type of animal thanks to the animal trait that we declared right here. So of course, you could feel free to implement other behaviors on your trait here. You can define other function names and signatures that you want to be implemented across all of your different animal types. And what's cool is that you can even combine traits together. So let's say that certain types of animals are not dangerous. Okay, so let's say that we had a dog here, and we have a trait called not dangerous. And we're just going to assume that all dogs are not dangerous. Obviously, some breeds are more dangerous than others, but we're just going to assume, for the sake of example, that all dogs are not dangerous. So we're going to come right after our struct dog here, and we're going to say impl not dangerous. And we're just going to do an empty set of curly braces there. So now the dog struct has the not dangerous trait along with the animal trait. So it's an animal and it's not dangerous. Same thing for a cat. Let's implement the not dangerous trait for a cat here as well. Of course, a bear and a tiger are both dangerous types of creatures, so we probably don't want to have those as pets, right? So if we come back to our person type right up here, right now we are allowing any animal to be a pet of the person. But if we only want to allow and go further restrictive with our trait boundaries here, we can actually add in the not dangerous trait in order to restrict which types of animals are allowed. And the way that we do that is with the plus sign. So we're basically adding multiple traits together so that they're being kind of conglomerated together. So basically all of these traits must be satisfied in order to use that type for pet type. So we'll do animal plus not dangerous and just auto complete that. And we should be able to implement that here. Of course, I just realized that I totally forgot to say for dog and for cat. So we need to make sure that we implement the trait for these specific types. So don't forget to do that as well. Say for dog and for cat. And of course, we don't have that implementation of not dangerous for the bear and tiger types. All right, so now that we have this trait boundary that says animal and not dangerous, what would happen if we try to run our application? Well, dog barked because a dog is not a dangerous animal. Let's try substituting the pet number 2, which is a cat, and it says cat meowed, right? Because it's not dangerous. So let's try passing in maybe pet number 3 and check it out. We get this exception here because it says that the boundary of not dangerous hasn't been implemented for the pet type generic argument, and therefore we cannot use it as a pet on the person type. And the same thing will apply for pet 4, which is a tiger. Once again, you're going to see this exception that says that only the cat and dog implement the not dangerous trait. So therefore, cat and dog are the only valid value. So again, the Rust compiler is being extremely helpful. It's trying to inform us exactly what's wrong with our code. And it's even telling us the valid inputs that we could use for this particular argument during our person construction. So this is kind of how generics work. It's a really powerful feature, and hopefully this example of using people, pets, and specific types of animals has been informative and educational to help you understand exactly how this concept works. Now, there is an alternative syntax that you can use for trait boundaries right up here. So right now we just have the trait boundary after this colon, but it's directly after the generic declaration here. And oftentimes you'll see generics just referenced as T for type, but you can actually use a name like pet type if you want to, just to make your generics more readable. I don't really like using single characters because it just makes your code look really confusing. Type T, type Z, type U, type P, whatever it is, it just gets kind of confusing. But when I look at a person type here and see a generic called pet type, it's pretty obvious to me that that's referring to a specific type of pet. So what we can do is just let's copy or cut out the animal and not dangerous traits here. We'll get rid of that colon right there after pet type, the pet type generic. And then what we can do is say where, and we can do pet type colon, and then specify these over here. So this helps. This is just a different syntax that you can use, but this helps to make things a little bit more readable here. So if you did specify multiple generics, which you also can do, then over here, we can just kind of separate out the trait boundaries from the actual declarations of our generic input arguments. So if we wanted to, we could add other fields down here that do have other types of generics here. So for example, we could say pet number 2 could be a pet type 2. So these are 2 different generics that we're declaring here. And of course, as soon as we save that, you'll see that we get this error because we haven't declared pet type 2 as a generic. So let's go up here and say pet type 2. And let's say that for pet type 2, we only want to allow dangerous animals. So your first pet can be a not dangerous animal, but your second pet can be a dangerous animal. So what we'll do is specify that pet type 2 can be an animal and it has to be dangerous. But of course, we haven't actually implemented the dangerous trait yet. So what we'll do is just say trait dangerous. And right down here, we'll implement dangerous for bear. And then we'll also implement dangerous for the tiger struct as well. And then down here on this line where we are instantiating our person, we of course need to now specify pet 2. And pet 2, if we try to make it a P1, for example, remember that P1 is a dog, right? So we have dog right up here. So pet number 1 is going to be pet number 2, which is a cat. Pet number 2 is pet number, whoops, let's do pet 1 here. And so as you can see, the dog does not satisfy the dangerous trait. Only the bear and the tiger implement the dangerous trait. So therefore, only the bear or the tiger can be used as pet number 2. So if I try pet 2, that's the cat. So once again, the cat does not implement the dangerous trait. But if I use pet 3, which is a bear, then you can see that that compiles and runs just fine. And if I use pet 4 as the second dangerous pet, then we can run that and it compiles just fine as well. And the reason that you're not seeing any output from the bear or the tiger here, even though it's compiling, is because we are only calling make sound on the first pet, not the second pet. So we could just duplicate this line, reference the pet2 field, and then call the make sound function or method because the animal trait that declares the make sound method has been implemented on both not dangerous and dangerous animals. So anyways, that's all I've got for this particular video for now. Hopefully this gives you a better understanding of how generics work and how traits work inside of Rust. And thanks for joining me again. Please leave a like if you learned anything new from this video. Leave a comment down below. Let me know what you thought of this video. And please subscribe to the channel to help me grow this community because I am an independent content creator and any support that you can provide would be extremely helpful. Thanks again for watching and we'll see you soon.